Now we're going to do experiment 7, converging lens, image, and object relationships. What you see in front of you is the object screen for this lab. It consists of a couple arrows. The one we're going to focus on is the vertical arrow that is pointed down. It has lines that are 1 millimeter apart, and the whole arrow is 20 millimeters from top to bottom. I'm going to set this up on the light table in such a way that then we can look down the table and we're going to be able to see the lens, which is currently 250 millimeters from the object, and beyond that we're going to be able to see the image. Now what we're going to do is to take a look at how some of these things work. Now I don't know if you can see it clearly, but the image as it stands right now is pointed up, and if you remember, the object had the arrow pointed down. The image as we see it at the current time has a distance of from the lens, a DI of about 110 millimeters, and the height of the image is about 8 millimeters. Make a note of those on your data table. We're going to come back to that. So as you see, the first page of the lab shows us a number of equations for the lens, and then starts the questions at the bottom of the page. Is the image magnified or reduced? Is it inverted, etc.? Which I think you can see if you compare what we've done already. I will show you this, tell you this. On the second page of the lab, the questions are misnumbered. Number 3 should be number 4, 5, 6, 7 going down the sheet, which is a problem because question number 5 refers to question number 4, and if they're not numbered correctly, that doesn't make sense. So what we're going to do now is we're going to start to fill out the data table as you see it there on page 20 on your lab handout. The image distance we're going to measure, and the height of the image. The object distance we're going to set according to the chart. What I'm going to do first is I'm going to start at 250 because that's where we are currently, and I'm going to move the lens, and then I'm going to move the screen till we can focus the image on it. So we start at 250. I'm going to move the lens out 5 and go to 300, and then I'm going to slide the image screen until we get a clear, there we are, a clear image of that. So at 300, our image distance, I'm reading it on the side of the light table, which is harder for you to see, so I'm going to tell you this, but the image distance is about 100 millimeters here, and the image height is about 7 millimeters, which I'm reading off of the scale that's right here on the screen. All right, I'm going to go ahead and move the lens out another 5 millimeters, and I'm going to slide the screen out some more until we get it focused again. There we go. So at 350 millimeters of object distance, I have an image distance of 96 millimeters, and I have an image height of about 5.5, let's say 5.5 for the image height. All right, let's move it out again, and we'll go to 400. And then we'll focus this on here at, there it is. So at 400, I have, let's say, 92 millimeters of image distance and 5, we could say, like, let's say 4.8 millimeters of height on that object, or on that, sorry, on that image. Okay, now we're going to go to 450. And I'm going to focus in on the image again. Ooh, it's getting pretty small. At 450, we have about 90 millimeters to the screen, so the image distance is 90, and the height of the image is 4 millimeters. Now I'm going to go, let's see if I can go to the last one here, to 500, and see if I can get a reading on this. Right at the end of the light table. Yeah. Alright, I'm just not getting a 500. We're not going to be able to do that. Alright, so I'm going to come back. I'm going to bring the lens all the way back to 250, where we started, and bring the screen up till we have an image. Okay. There's our lens. There's our image. I didn't focus it good because I'm going to go right away and move the lens closer so that it's at 200 millimeters from the object. And now I'm gonna sight this in. Ooh, yeah, nice good image there. Okay, so at 200 millimeters, my image distance is 12 millimeters, 120 millimeters, and the height of that is looks like about 12 millimeters. Okay, now let's move the lens closer. So now we're down to 150 millimeters, and I'm going to move this in. There. Nice picture there, nice image. So at 150 millimeters of object distance, my image distance is 150 millimeters. Oh, that's interesting. I bet we're going to have to know that. And the image height is 20 millimeters. Wait a minute, I think the object height is 20 millimeters. That's interesting as well. All right, I'm going to go ahead and move the lens closer. I'm going to move it now to 100 millimeters of object distance. And let's see where our image focuses best. Interesting. My image is focusing at 100 millimeters of object distance. My image is focusing at about 290 millimeters. So my image distance is 290, and my image height is pretty much taking up the whole screen here. It's about about 50 millimeters. Okay, I'm going to move closer, and we're still, so we have the object is pointing down, the image is pointing up. I'm going to go ahead and move it closer, so I'll be at my 50. There, I'm at 50. Now what are we going to do here for, oh, look at that. That's really interesting. I'm actually focusing, I moved it in close. That's actually focusing the filament. That's not what I want. I'm not focusing on my object, I'm focusing on the filament at that close. So let's go out, 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 out. I'm not really getting anything here. I'm going to do something. Okay, I switched off the rim light. I'm going to actually lay put the screen down under here. And let's look over here on the wall. I don't know that you can see it yet, but I'm going to move my lens closer and further away until all of a sudden, now I'm seeing my image projected clear over here on the wall, actually quite clearly.